All right, let's go ahead and get started. For our first question for our warm-up, we're taking these complex fractions and we're going to simplify them into unit rates. So basically that means we're going to divide them, just like we did yesterday. We're going to take the numerator and divide it by the denominator. So all we are doing here is taking both the numerator and the denominator and dividing it by the denominator's value. So we're going to do 20 divided by 2/3, and we're going to do 2/3 divided by 2/3, and that's going to give it to us in the unit rate. So if we do 20 divided by 2/3, that's going to come out to 30. Okay, same thing for number 2. We're going to take 1/4 over 3, and we're going to divide them by the denominator, which happens to be a 3. Okay, 1/4 divided by 3, that's going to come out to 1/12. And of course, 3 divided by 3 is a 1. We don't have to put the over 1 part. So just 1/12 is what you should have gotten. Okay, now for here, given the following, we've got 60 miles over 1 hour, 120 miles over 2 hours, and 190 miles over 3 hours. Which one of those ratios is considered to be a unit rate? Which one is a unit rate, Christopher? The 60 miles. That's correct. The unit rate is going to be that 60 miles over 1 hour. Because remember, 1 as the denominator takes it into a unit rate. So 60 miles over the 1 hour is going to be considered our unit rate. Now, if a driver travels 120 miles in 2 hours, is his average speed going to be 60 miles per 1 hour? Yes or no? Yes. Jeremy? Yes, right? It is. If we go ahead and take 120 and we divide it by 2, that comes out to 60 over 1. So yes, it is going to be the same. It is an equivalent ratio there. Now, if the driver drives 190 miles in 3 hours, is that the same thing as 60 miles per 1 hour? No, it's not. If we were to go ahead and do 190 and divide it by 3, let's do 190 divided by 3, that comes out to 63.3 repeated miles per hour. Okay, that's not the same. That's not the same thing as 60 miles per hour. Okay, so we're looking for things that are equivalent, just like we did yesterday. All right, let's go on to the next slide then. So talking about the difference between proportional and non-proportional information. Proportional versus non-proportional relationships. Now, what's really important to make sure you understand, when we talk about the word proportional, I'm going to highlight that one in pink. Proportional means that you've got two quantities that are identical in their unit rate. If it's proportional, their unit rate is going to be identical throughout the entire problem. So let's write that down. For proportional, two quantities are proportional. If they have identical unit rates throughout the whole problem. It means the unit rate has to be the same for every example of that problem. Okay, now if we're talking about non-proportional, non-proportional means that they don't have identical unit rates. Okay, so if the quantities are non-proportional, then they will not have a consistent unit rate. Okay, their unit rate will change throughout the problem, or when doing a comparison between two different examples, their unit rates will not be the same. So we saw that yesterday when we were working with the example of the two people with their pencil pouches. Okay, one person had a pencil pouch that, simplified down to a different unit rate than the other person's. Go ahead and get that copied down. Now, one thing that's really important to make sure that you keep in mind when we are setting up ratios, there's some values, some units that will be predetermined to where they go in a ratio. So, for example, if we ever are comparing anything involving money, money always goes on the top, okay? If we're comparing money, money always goes on the top. So, money will always go over a quantity. Okay, same thing when we're comparing with time. Time has a very specific spot that it always goes on. Time will always go on the bottom of a ratio. So you would always take a specific quantity and put it over time. And then sometimes instead of giving you a word problem, we might be giving you information in a table format. In that case, if we give it to you in a table format, we always put our y values on the top and our x values on the bottom. Our y values always go on the top, our x values always go on the bottom. So these are some important things to make sure that you keep in mind, so when we're setting up a ratio, you know how to properly set it up if these items are involved. Okay, so let's take a look at this first problem. It says Andrew earns $18 per hour mowing lawns. We want to know, is the amount of money he earns proportional to the number of hours that he spends mowing? So the amount that he earns, is it proportional to the amount of time he is actually mowing the yard? Okay, so we know that he earns $18 per hour. So what I'm going to do is I'm going to set up a table. And I know that my hours are going to be my X value. And my money, the money that he's going to earn, would be considered a Y value. And then we're going to go ahead and do our comparison here. So if he doesn't work at all, how much money will he earn? 0, right? If you don't work, you don't get paid. Now, if he works for 1 hour, how much money is he going to earn? $18. If he works for 2 hours, how much money is he going to earn? $36. Good. Let's say he works for 3 hours. How much money will he earn? 54. Benson, your ability to multiply those quickly in your head is fantastic. All right, let's do one more. 4 hours. If it's 4 hours, then how much is he going to earn? 72. Very good. Okay, so this is a table of sufficient amount of information. Okay, we know that if he doesn't work, he doesn't earn anything, and that each hour he works, he's earning $18 additionally, right? So what we're going to do is we're now going to check the unit rates. The very first value, 0, 0, we don't worry about that because 0 over 0 is always going to come out as an error. We're not going to worry about that amount. What we are going to focus on is all the rest of the amounts. So when we're setting this up as a unit rate, remember, unit rate is always money on top and time goes on the bottom. So that means we're going to be checking this as 18 over 1. And then we're going to be checking this as 36 over 2. And 54 over 3. And 72 over 4. We want to see, are they going to all be the same value? So 18 divided by 1 is what, guys? 18. 18 divided by 1 is going to give us 18. What about 36 divided by 2? 18. Okay, what about 54 divided by 3? 18. Good. And 72 divided by 4? 18. Okay, so is the unit rate consistent throughout the entire problem? Yes, it is consistent throughout the entire problem. That means that this is a proportional relationship. So let's write that down. This is proportional. And we want to write down why. Because we have a consistent unit rate. Of $18 per hour. We have that consistent unit rate of $18 per hour. So that makes it a proportional relationship. All right, let's take a look at the next problem we have here. It says, quiet. It says Uptown Tickets charges $7 per basketball game plus a $3 one-time processing fee for the ticket order. So in order for you to start placing an order, you have to pay a $3 fee. Okay, so that's usually how it works online. If you go to things like Ticketmasters and you're wanting to buy tickets for a concert, you have a charge that you are paying as a one-time charge. Okay, so before you can even buy the tickets, you have to pay this one-time charge to be able to purchase the tickets from the site. That's how they make their money. Okay, so we want to know, is the cost going to be proportional to the number of tickets that are going to be ordered? So what we're going to do again is we're going to set up a little chart, a little table here of information. So let's go ahead and put tickets as our X value, and then our Y value again is going to be the money, how much it's going to cost. So for here, before we buy any tickets, so if we know we're going to be making a purchase, we are going to be ordering something, before we put any tickets into our cart, how much money is being charged to us? So again, looking at the problem, it's $7 per ticket, plus you've got a $3 one-time processing fee. So before I even start putting tickets into my cart to buy, how much am I being charged? $3, right? We're being charged that one-time $3 processing fee in order to do the ticket order. So before we've even purchased any tickets itself, we're being charged $3. Now, if we go ahead and we add one ticket into our cart, now how much money are we going to be charged? $10, right? It's $3 for the one-time processing fee, plus the $7 for the ticket. So we get $10. 7 plus 3 is going to give us 10. Make sure you're paying attention to this. Sophia? Okay, now, when we buy 2 tickets, we're going to buy another ticket. So if we're buying another ticket, how much money are we adding onto it now? Another $7, right? So add another $7 onto it. How much is it going to cost us for 2 tickets? 17, right? If we did 2 times 7, that's 14. 14 plus the one-time processing fee, 14 plus the 3, is going to come out to 17. Let's do this again. If we buy 3 tickets, if we purchase 3 tickets, now how much is it going to cost us? 20 what? Not 27. Remember, each ticket costs how much? $7. So if I'm adding another ticket, I'm just adding $7. So it's 24. And if we go to 4 tickets, now what's the cost going to be? You're just adding another $7. It's 31. Okay? So again, what we're wanting to do is we want to identify what the unit rate is. Now again, we do not start at the point 0. Okay, because 3 over 0 is always going to come out to an error. Okay, anytime you put 0 as a denominator, it comes out to an error. So what we're going to do here is we're going to do 10 over 1. We're going to do 17 over 2. We're going to do 24 over 3. We're going to do 31 over 4, and we want to see if those are going to come out to the same. And I'll zoom in so you can see my chart a little easier. If we do 10 divided by 1, what's 10 divided by 1? Is 10. Yeah, 10 divided by 1 is just 10. If we do 17 divided by 2, then we're going to get 8.5. If we do 24 divided by 3, we're going to get 8. If we do 31 divided by 4, we're going to get 7.75. So are these the same unit rates? No, right? 10, 8.5, 8, 7.75. They are not the same unit rates. So therefore, this is not proportional. This is non-proportional. Because the unit rates are different, right? They are not consistent throughout the entire problem. So that makes it non-proportional. When the unit rates are different, it's non-proportional. Okay, let's go ahead and go on to the next problem. I'll leave this up for just a second so that you guys can get that copy down. Pause. All right, let's go to the back page, or the next page. Okay, so what I'm going to have you guys do here is I'm going to go ahead and set the table up for you, like what the table's format is going to be, and you're going to fill in the information about the table and then identify whether these are proportional or non-proportional relationships. So for problem 3, Anna walks 6 miles per day. If this number of miles, or is the number of miles she walks proportional to the number of days that she's walking? So what we're going to do is we're going to set days up compared to miles. So I want you to find it for 0 days, 1 day, 2 days, 3 days, and 4 days. Okay, for problem 4, a recipe for fruit punch calls for half a cup of sugar to be combined with 2 quarts of juice mix. We want to know, is the sugar proportional to the juice mix? So we're going to put juice mix on top of our table, and we're going to put sugar on the bottom of our table. And I want to have 0. And then for here, we'll go ahead and we'll count by 2s. We'll go 2, 4, and 6. We'll just do those values. Okay? And then Josh has $120 in the bank. Each week he deposits another $20 into his account. We want to know, is the number of weeks proportional to his deposit? So we've got weeks that are being compared to the money that he's got in the account. So at 0 weeks, at 1 week, at 2 weeks, at 3 weeks, and at 4 weeks. I want you guys to go ahead and fill in those charts and then identify whether they are creating proportional relationships or not. And if they are proportional, what was the unit rate? All right, let's go ahead and go over this real quickly. So Anna's walking 6 miles per day. We want to know if it's proportional, the miles is proportional to the days. So if she is at 0 days, how many miles has she walked? 0. 1 day, how many miles has she walked? 6. 2 days? 3 days? 4 days? 24. Okay, so if we set this up, we're going to do 6 over 1, which comes out to 6. We do 12 over 2. That also is 6. 18 over 3 is also going to be 6. 24 over 4 is also going to be 6. So are these proportional? Yes, right? They are proportional, and the unit rate is 6. So that's what we're going to write down. It is proportional, and the unit rate equals 6 miles per day. Okay? It is a proportional relationship. Unit rate was 6 miles per day. Let's take a look at problem 4. A recipe for fruit punch calls for half a cup of sugar to be combined with 2 quarts of juice mix. Okay, so if we don't have any juice mix, how much sugar are we going to have? 0. When we had 2 quarts of juice mix, how much sugar did we have? When we had 2 quarts of juice mix, how much sugar did we have? 1/2. We just had a half. If we've got 4 quarts of juice mix, that means we're going to have 1 cup. If we have 6 quarts of juice mix, we're going to have 1.5 cups of sugar. Okay, so now we need to identify if it's proportional. So we're going to set this up as a half over 2, and 1 over 4, and 1.5 over 6. And all of them happen to come out to 1/4. They all come out to 1/4, or 0.25. So it is proportional. It is going to be considered proportional. And the unit rate is 1/4. So 1/4 of a cup of sugar per 1 quart of juice mix. Okay, you always want to make sure you identify what the units are. Okay, for number 5, Josh has $120 in the bank. Each week he deposits 20 bucks. So is it proportional? So at 0 weeks, how much money does he have in the bank? 120, right? He starts with $120. After 1 week, how much money is he now going to have? 140, right? Because he's adding $20 into the account. At 2 weeks, he's now going to have 160. At 3 weeks, he's going to have 180. Thank you, George. Huh? Because at 0 weeks, he has $120 in the bank. He started off with $120 in the bank. Each week, he then increases by 20 bucks. So by week 4, he's going to have $200 in the bank. So here, we've got 140 over 1, which is equal to 140. But then we've got 160 over 2, and that's going to be equal to 80. Then we've got 180 over 3, and that's equal to 60. Then we have 200 over 4, and that's equal to 50. So are those consistent? No, those are not the same. So this is non-proportional. Non-proportional. Okay, in order for it to be proportional, there has to be a consistent unit rate throughout the entire table, throughout the entire piece of information. If it's not consistent, then it is non-proportional. Go ahead and get that down real quick. Let's make a note of the stuff that was proportional versus non-proportional. If you look at each one of our proportional graphs or proportional tables versus our non-proportional tables, what's one thing that you noticed? Is there anything about the tables that you've noticed? Here's our proportional. Here's a proportional. Here's a proportional. What do they all seem to have in common, George? Okay, they've got some even numbers. There's something more important, though. Daniel? They all start at 0, 0, right? They all are starting at 0, 0. And look at our non-proportional ones. Our non-proportional ones start at 0 and then another number. 0 and another number. So proportional graphs or proportional information, they all start at 0, 0. So if we go to the next page, when we're looking for proportional information and it's given to us as a graph, then you're going to create what's called a straight line that goes through the origin. Okay, if it is a graph, the graph is going to be a straight line, and it has to go through the origin, and the origin happens to be 0, 0. It's that corner point. All proportional relationships start at 0, 0. And then they continue to graph at a straight line. Okay? So if we're looking here at this information, we've got tennis balls, how many, and then the cost. So the number of tennis balls is the X value. The total cost is the Y value. What we're going to do is we're going to plot these points as our X. So this is our X and this is our Y. We're going to plot those points on the grid. So at 3, 6, we're going to go to the right 3 and then up 6. And I'm going to graph that point there. Then we've got 4, 8. So I'm going to go to the right 4 and up 8. Then we've got 5, 10. And then we've got 6, 12. And I want to know if that's going to be a proportional relationship. So what I need in order to be able to check that, if it has to be a straight line, I need a straight edge, which means a ruler is going to be necessary. And I'm going to connect the points and see if I can connect it through the origin. So when I connect the points, it forms a straight line, and I can extend it to the origin, which makes sense, right? If I'm not buying any tennis balls, is it going to cost me anything? No, right? The $0 for 0 tennis balls. So this creates that proportional relationship because it goes through the origin, and it creates that straight line. And again, to graph this, if we're looking at the point 3, 6, that means we're going 3 units to the right and then 6 units up. 4, 8 means we're going 4 units to the right and 8 units up. Okay, 5 units to the right and 10 units up. 6 units to the right and 12 units up. Okay, that tells us the direction that we're actually moving. And this is a proportional relationship. And then our unit rate is where X is equal to 1. So we just have to look at where X is equal to 1. X is equal to 1, I follow that line up, and here's my point for my unit rate. Y is equal to 2. So my unit rate is $2, because that's what the Y value is, per 1 tennis ball. My unit rate is $2 per 1 tennis ball. So again, you need to make sure it's a straight line. It goes through the origin, and that makes it proportional. And if it is proportional, you should be identifying what the unit rate is. The unit rate always is at where X values are equal to 1. Let's go on to the next one. Okay, I want you guys to graph these 4 points, connect them, and see if it can extend to the 0, 0 point and still form a straight line. If it does, then you need to identify what the unit rate is. All right, let's go ahead and graph these points real quickly. We graph it at 1, 4, at 2, 8, at 3, 12, and at 4, 16. Is it going to form a straight line?
No.
Yes. Is it going to go through the origin? Is it going to go through 0, 0?
Yes.
Yeah. If I connect them, it will go straight line through the point 0, 0. So it's a straight line. That's a check mark. Passes through the origin. Passes through 0, 0. That's a check mark. So that means that it is proportional. This is a proportional relationship. Okay? What is the unit rate? The unit rate is at the point 1, 4. This is our unit rate right here. That's where our unit rate is. So that means that it's going to be 4 quarts for 1 gallon. The unit rate is 4 quarts per gallon. 4 quarts per gallon. Okay, let's go ahead and get this moved to the next one. So for here, they're not giving you the table, but you can make a table of information. Rachel baked 3 cakes in 2 hours, 4 cakes in 3 hours, and 5 cakes in 4 hours. So we're going to go ahead and make a table where we've got the X value being our hours, and the Y value is going to be the number of cakes. And for the first thing, it says 3 cakes, 2 hours. So that means we're going to have it at 2, 3. Then we've got 4 cakes, 3 hours. This is 4, 3. I'm sorry, oops, backwards. 3, 4. Then we've got 5 cakes in 4 hours. So 4, 5. So there's going to be our table of information. We need to plot those points. So we're going to plot it at 2, 3, at 3, 4, and at 4, 5. Now, let's go ahead and connect them. Does it form a straight line? Am I able to connect them to form a straight line? That's not a straight line? Yeah, that is a straight line. So it is a straight line. Does it go through the origin?
No.
Okay, so origin is a no. So is it proportional? No. Okay, remember proportional means it has to go through the origin and it has to be a straight line. So this is non-proportional. Non-proportional because it didn't go through 0, 0. It is not proportional because it did not pass through the points 0, 0. I want you guys to do the last question on your own. That's the last page of the notes. Do that last question on your own. All right, let's take a look at this one. We've got the number of minutes that we're comparing to the calories that are being burned. Number of minutes compared to the calories that are being burned, because that's what the table says, right? The chart, the graph. Minutes are our X. Calories burned is going to be the Y. Now it says a person can burn 8 calories per minute. So at 1 minute, they burn 8 calories. At 2 minutes, it should be 16 calories. At 3 minutes, it should be 24 calories. At 4 minutes, it should be 32 calories, and then so on and so forth. Okay, so if I start graphing this, at 1 minute, it's going to be at 16, which is roughly around right here. At 2 minutes, it's going to be, or sorry, not 16, my bad. At 1 minute, it's going to be at 8, which is roughly around here. At 2 minutes, it's at 16, so ignore this one. At 3 minutes, it's right at 24, just right below the 25. And at 4 minutes, it's going to be at 32. Okay, so now if I graph these, it is going to form a straight line, and it is going to be proportional because it does cross through the origin. So it is proportional because it's a straight line, goes through the origin, and our unit rate happens to be this very first point right here, which is at 1 minute, 8 calories. So the unit rate is 8 calories per minute. 8 calories per minute.